So here we are, the Doodle Labs booth, AAVSI 2024. I got Amol Parikh, head of marketing. Amol, we've known each other for a long time. I know about your products, but not a lot of everybody knows what Doodle has in terms of the product line. You guys do a ton of stuff. Can you chat at kind of what's the newest? I mean, I know folks know kind of the Mini, the wearable radio, which I think they actually are showing another right over here, yes. And then I've integrated the Nanos before, but this is new.
Yeah, and it's a little new and old kind of combined. So before we got into mesh radio products, we actually were just focused on long-range Wi-Fi. That's what this transceiver is. We've actually seen a lot of interest in this come back around. This has been going into like every Boston Dynamics Spot Dog, every Airbus A20. We've been selling those for a long time. But when we focused on robotics, we really moved into mesh radio networking because we saw that we needed to actually build out our tech stack instead of putting it on to the customer for that reliable long-range comms. But then we actually integrated the 11AX chipset. Just like 5G has been to LTE, 11AX is to Wi-Fi. It's just gangbusters in terms of...
So you can see the throughput. I mean, that's like 4.8 gigs.
That's right.
That's crazy. Okay.
That's right. In less than a millisecond of latency. It is incredible, but it's also our lowest price option.
Yeah, I mean, you can see this is the size of a stick of gum.
That's right. That's right.
Can you talk about pricing?
Absolutely. We even listed.
Oh, sweet. Okay, awesome. So about $100, $270 depending on which one you get.
As we do everything at Doodle Labs, we volume price, and so as you get into larger volumes, price comes down. Okay. But this is really our low-cost option. And then I think the thing that you and I were talking about before this is really what we're working towards in terms of our roadmap, which we're quite excited about. Again, we have our whole Mesh Rider lineup. It incorporates a lot of technology. Recently, we've had a lot of use of the Sense technology, which are interference avoidance, specifically in Ukraine. Because
that's the frequency hopping, right?
It's a frequency hopping. Maybe something to show here. All of our Mesh Rider radios are multi-band. And that's what these are, model numbers across the bands that they actually cover. And what that allows us to do with Sense is you take advantage of the fact that you now have basically multiple highways to run on simultaneously, and you can actually move between them. So jamming is just intentional interference on the band. Even in unlicensed frequency bands, you're facing that just from Wi-Fi noise or other things like that in urban environments.
So not just defense customers, but industrial, enterprise, public safety.
Big time on the commercial side as well. We see it on drone delivery, all kinds of urban operations, because you're fighting with a lot of Wi-Fi noise. Or in agriculture, you're actually usually often the big cell towers that emit 900 noise in the 900 megahertz band. So just noise is the problem, and jamming is just intentional noise. And so you just need a way to be able to avoid that and actually have a clean signal.
Can I ask, so is this here, like the Sense technology, is this automatically hopping, or can I choose which channels as well?
You can manually choose it, but Sense is designed to be automatic.
Beautiful.
And so then that's what's, using the intelligence on board to make that switch really fast. We're switching between bands in less than 100 milliseconds.
Can you expand, is this what was on the Helix?
Yes, exactly. So Sense is an add-on to that. Not everyone is taking advantage of it, but specifically in the defense use cases in Ukraine, that is actually the thing that is making our multi-band thing supercharged, more capable.
And so I can buy, so is this an additional add-on for a radio?
That's right.
Like a software capability, like Tesla Autopilot type
stuff. Licensing, it's exactly that.
Beautiful, And then you see here, Blue UAS framework, NDA compliant. Where do you guys manufacture these out of?
Out of Singapore.
Dope, okay.
And so then the thing that we were talking about is actually leveraging this platform or this hardware and actually running a light version of our Mesh Rider OS. So we can actually bring interference avoidance, anti-jamming to this.
Beautiful, okay.
And so again, very low cost, very small, but then taking advantage of those advanced capabilities that really mean a lot.
And so it's a la carte. So similar to the Sense thing, I can enable, Mesh, for example, on this, or Sense, or other types of frequency hopping.
Some of the core capabilities of Mesh Rider, that's right. So Sense is one of them in terms of taking advantage of our multi-band. Actually, we'll have, again, multi-band operation to be able to use Sense, that kind of thing. Because right now, these actually are house multiple frequency bands, 2.4 gigahertz and 5, but you're using one at a time. At that one, you're going to be able to dynamically move.
With this one, you got 4, right?
This one's 4. We also are releasing a 2x2 11AX as well.
And will that be even smaller than this?
No, actually, it'll be very similar.
But a little bit cheaper, probably.
Yeah.
So basically between 100 and 270 bucks for these low-cost, robust radio links. It says right here, but you get about 10 kilometers of range, I think. Where does that say?
You actually put range on the other ones, because one thing that's actually kind of unique about this platform is we actually are, and it's the reason we designed this, the capabilities are really around the tech stack that the customer builds around these transceivers, because they are just simple transceivers. And so we have that full multiple tens of kilometers range capabilities, but the performance of the drone or the robot is dependent on what they build around it. Again, the compute for actually using that version that we're just going to use Mesh Rider Lite is actually going to be based on a single board computer that is a companion board.
Okay, so this requires some like onboard compute, so say like a Voxel 2, NVIDIA, Raspberry Pi, some sort of embedded system, right?
Exactly right.
Echo Map, etc.
Exactly
okay, cool.
Right. Versus the Mesh Rider platform, we've built that into the radio.
Okay, okay. Hence the size difference, etc. Okay.
Exactly.
And then this is really neat. Do you know when we're expecting to see some of this, the lower cost stuff?
You know, we're actually it's on our product roadmap, and we're kind of using this opportunity to kind of see what the interest is in the market, and it's been pretty high. So I think that'll help influence things.
The cheaper the radio link, the better, because it saves BOM costs, increases margins, all that stuff.
What we're seeing is actually a lot of the interest comes in from FPV platforms that want to have that interference avoidance, anti-jamming capability. Really low cost, attritable platforms that need simplified hardware, but that core capability to actually be performative. So from that point of view, the demand is like they want it tomorrow.
Okay. Yeah. So if you have any questions, you can email Ashish or Jeff or anybody.
Email us at sales@Doodle Labs, and the team of us are going to pick it up.
Awesome. Dude, I really appreciate it. Thank you guys. Always great seeing you.
You too, brother.